remember first, as I said, this whole goal 9, super goal 9, deals with inequalities. So today we're talking specifically about conjunctions and disjunctions, okay? This will also play a part for goal 9.3, so it's important to really make sure you got this today, okay? A conjunction, two statements joined by the word and. To be true, both statements must be true. The solution set is the intersection. So the main words that I have in blue are what you should remember, that an and is an intersection. And an intersection means what's common, what's the same, where do the graphs overlap each other. That's what an intersection means, okay? So there's two parts to every answer. You're going to have an algebra answer and you're going to have a graph answer, okay? So I'm going to be looking for two things for each answer. The solving is very simple. It's very simple solving, like the 9-1 that I gave back to you today. It's very simple solving, but getting the final answer written correctly and graphed correctly is another story, okay? So, solve and graph the solution set. Okay, so we'll solve both inequalities. We'll subtract the 2x. So we'll have 5x is greater than 10, divide, and x is greater than 2. And on the other side, we're going to subtract 5x, so we're going to have negative 3x is greater than a negative 15, and I don't know what just happened. It's back. And then divide by negative 3, ding, 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 ding. We're dividing by a negative, so make sure you switch the direction of the inequality symbol. X is less than 5. Okay, so that's not our algebra answer yet. Okay, so we go to our graph. When I do a graph, I only do as much as I need. I don't really do much more than that, and I'm not particular about that, so you don't have to make this big, involved number line. Okay, I want to know where your numbers are and that you can graph on a number line. Believe it or not, people still graph incorrectly on a number line. So I only need specific numbers that you're working with is good. So I'm going to do what I call my helper graphs. This is not a necessary component of your answer. The helper graphs are simply the individual graphs of the two inequalities. So whether you have this or not is going to be up to you. And the helper graphs I just put above the graph. So x is greater than 2. Looks like that. An open circle on 2 going to the right. And x is less than 5 is an open circle on 5 going to the left. So my final answer, well, let's do that in green. My final answer, I'm going to put on the number line. So this is why I don't care that you have the helper graphs. That's going to be up to you. The graph answer I want on the number line. Okay? So because this is an and, that means we're looking for what two things or what things are in common with these two graphs, where these graphs overlap each other, what do they share, because to be true they both have to be true. And then these graphs are overlapping between 2 and 5, not including 2 and 5 though. So my final graph looks like that. The two separate graphs overlap and have in common the numbers between 2 and 5, but do not have the actual 2 and 5 because they're open circles. Okay? So an and, when you're doing an and, that's what you're looking for. Where do these graphs overlap each other? Now, I'm going to refer to that, and I'm sure that there's not a math book in the world that refers to it, as a dumbbell graph. You know, those 2-pound weights that Justin uses at home, you know, right? Okay, so that's me. I'm just kidding. Okay? Those little dumbbell things that you use for weightlifting, strength building. Okay? So I'm going to refer to this as a dumbbell graph. Most ands are dumbbell graphs. Most, not all of them. You're going to see all 3 kind that we're going to talk about. But most ands are dumbbell graphs. When you write your algebra answer, this is what it looks like. I take my smaller number, I put a less than symbol, my x, and a less than symbol, and my larger number. If you put the smaller number on the left and your larger number on the right, they will both be symbols pointing to the left. They are not equal to, they're not closed circles, so I don't put the little line under the inequality symbol. Okay? So when you have a dumbbell graph, this is what your algebra answer should look like. X is between 2 and 5, exactly what the graph says. So your algebra answer and your graph answer need to match each other. Okay? It's not going to have the word "and" written in the answer. Questions so far? Let me get through all the types and we may go back and have some questions. Okay? Okay, the next one is automatically an "and." It does not say the word "and," but simply by the way it starts, it's an "and," because it kind of looks like my answer from the previous question. I have two inequality symbols in the same problem. So there are two approaches to this. One of them is more complicated. I don't do it. I do the easier way. And it's kind of like solving an equation that has three parts to it, or three sides, if you want to say. Your goal is to get x alone in the middle, so you're going to subtract 3 to do that. But that means you've got to subtract 3 from all 3 parts of the inequality. Not just the right or not just the left, but all 3 parts. So you're going to have negative 10 is less than or equal to 2x is less than 8. And then I'm going to divide by 2 on all 3 parts. So negative 5 is less than or equal to x is less than 4. This is my algebra answer. I don't have to create it this time like I did on the last one. And I know because of the way it looks, it's a dumbbell. I don't have to do any helper graphs. And again, look at that. Just simple negative 5 and 4. That's all I care about. That you know negative 5 would be to the left of positive 4 on the number line. Okay? I know automatically that this is going to be a dumbbell because of the way the answer looks. So I have a closed circle on 5, and it's closed because it's greater than or equal to, so it's got that little line under it which indicates that negative 5 is included, but less than 4, so an open circle on 4, and then the numbers between it. And then this is my algebra answer right here. So sometimes your question doesn't have the word "and" written in it, but when it starts like this with 2 inequality symbols, it's automatically an "and." Question yet? I'm not being too repetitive here because I'm showing you all the different kinds. Okay, next example. We have a conjunction, so we're going to solve each side. We're going to subtract 5. So negative x is less than negative 11. Divide by negative 1. Ding, 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 ding. You're dividing by a negative. Switch the direction of the inequality symbol. So x is greater than 11. On the other one, I'm going to subtract 7. So x is less than negative 9. Why did I do that? X is less than negative 9. So I go over to my graph. I need negative 9 and positive 11. My helper graphs, which are optional. Greater than 11, less than negative 9. This is an "and." An "and" is what's common, what's the same, where do the graphs overlap each other, and that's not going to happen. They have absolutely no values in common. So you have no final graph, and your answer is no solution. So no graph. If you have your helper graphs there, that's okay. There's nothing on your number line. Okay, so when I grade this, I'm going to look at the number line. What's on the number line? And that's what I'm grading. So here there's nothing on the number line. So it's correct. Okay, let's look at our fourth kind. We solve each one, so we subtract 2, divide by 2, so x is greater than or equal to 3. And on the one on the right of the and, we're going to subtract 7 and divide by -1. Ding, 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 ding. I'm dividing by a negative. Switch the direction of the inequality symbol. And we draw our number line. So my helper graphs would look like this. Greater than or equal to 3. Greater than or equal to 4. This is an and. And an and is where the graphs are overlapping, what numbers they share, what numbers they have in common, and that's going to start at +4. So +4 to the right is what they both share. These numbers right here only belong to the one inequality. So my answer is going to be from 4 up. My final answer. And it will be a closed circle because there's a closed circle on the 4. And then my algebra answer is x is greater than or equal to 4. So make sure that when you're finished, your algebra answer and your graph answer say exactly the same thing. Make sure they match. If you wrote for your final answer, x is greater than or equal to 3 and x is greater than or equal to 4, I would mark it wrong. You're being redundant then. Okay? A simple x is greater than or equal to 4. Okay, so let me go back here for a second. An and. So you got to remember that and is an intersection. What's common, what's the same, where do the graphs overlap? Most ands are going to end up dumbbells. And when you get a dumbbell, your algebra answer should be written as a combined inequality like this. Okay? If it doesn't say the word and it's written with two inequalities in the same problem, that's automatically an and. Okay? Ands can be no solution because it's possible that they don't have any numbers in common. And then ands can go in one direction. And there's some really weird things that can happen, but we won't cover those parts. Okay, so now let's go back and have any questions you might have. The key is really understanding what the word and means in terms of the problem. And means an intersection. Okay. Anything we want to go back and ask about there? Okay, let's look at the ors. The disjunctions. Now, why don't you stop there and start.